Okay, so welcome back, everyone. So we had a very interesting visit in Corbia, and now we are going to continue with the presentation that I wanted to have to explain a bit what are the next steps. So most of your system are still in the design phase, and but a lot of you are starting to see the manufacturing phase, or even a few are already inside. So I wanted to show you what is expected from your side with regard to this phase. So I will start by showing the overall system engineering phases of ITER. So this is applicable for any system from ITER. It's not only INC. Each ITER system should follow this approach. So on the top left, we have what we call the design phase with the conceptual design, which is ending with a CDR, the preliminary design, which is ending with a PDR, and the final design. So once we finalize the final design, we are not yet entering the manufacturing stage, because the manufacturing is the red area here, which is called manufacturing and delivery. So in between, there is something called manufacturing, design, and preparation. So we're still officially a design phase, which is commonly called the detailed design. So when we are reaching the FDR, at least for the ANC part, we have not designed everything that we can give to a company that will manufacture the ANC cubicle for us. We need to go through this phase to give the more details. So I just want to give a very brief reminder of what is expected during the main design phase, so that to refresh everyone's memory, and maybe on Thursday, Sukmit will also have a look on that. So at a CDR, what we expect is that we have the INC use case fully developed. We want to see the high-level FBS and high-level architecture. And so it's very important also that we have an INC cubicle reservation, which makes sense with regard to the needs of your system. This start to be very critical situation on ITER to get new space for cubicle, not only because of the space that a cubicle takes, but also because of the cabling change it represents. So we are still capable to get new cubicle or to remove one, but now it's a much more complex system. So we need really to be careful from the very beginning of a system with these aspects. There is one deliverable, which is the INC overview document, which gather all this information. After at the PDR, we start really the design. We expect the INC use case completely fulfilled, the operation procedures, the FBS defined with the variables, the INC architecture, including the COTS device selection and the INC signals. We want a preliminary version of the cubicle configuration that we are able to validate the weight, the power, the dissipation inside the cubicles. We want to have a good view on the interface with Kodak, presentation of the state machine, and some ideas on the HMI concept, and also the test scenario. So the two main deliverables, they are INC SRS and INC SDS. We usually ask to have a INC STP, HMI concept, and INC cubicle configuration as a separate document. But the content may also, you can decide to have the content only presented in INC SDS. The very important tool for design phase is the enterprise architect. So Sukmit will present on Thursday the updates on the methodology that we are doing, but this is the key tool to perform a design for a PDR and also for FDR. So at FDR, we have exactly the same deliverables. We just expect to have a refinement of the PDR activities. So for procedure, we want to have mapping to function and to state, a full description, exception handling and procedures. We want to have all variables. We want to have a full description of HMI. We want to have a full description of the algorithm. We want to have the STP with all the acceptance criteria included, signal chain fully developed, obsolescence management, and a bill of material. Everything again done with enterprise architect. So I think this message was already conveyed a lot of time during Kodak workshop. Everything can be found in the diagnostic methodology guideline, but I just wanted to remind it before I go to the next step. So the next step is presented a bit schematically on this slide, and I want to make the distinction between three things. So the what we call the plant INC system, and then the hardware and the software. So up to FDR, we consider the system as a whole. We don't separate hardware or software. They are both aspects of a system. When we start the manufacturing design phase, there will be activities which remain at the system level, but there are activities which will be purely hardware and activity which will be purely software. And the goal of the MRR is really to focus on the hardware. The software aspect, when we look at the criteria for MRR, we will have a look later. It is really not much relevant for software development. And we have to think that MRR has been thought for all the ITER system, and it's not really meant for INC in particular. So very often we consider the criteria that need to be checked at manufacturing is that we are able to launch big, costly manufacturing activities, so that we don't want to waste materials or expensive materials or expensive hardware when we launch a manufacturing. For the software, we can erase the software. It doesn't cost anything else than the time you have spent on it. So there is no. We have not this idea of really starting a manufacturing without making any mistakes. So we can start software at CDR if you want. It will not prevent anything except that you may have lose a bit of time, but it's not an issue. So in this scheme, what I show is that what we expect for manufacturing design phase at system level is to develop to write a document called INC SMS, the System Manufacturing Specification, and to develop further the INC system test plan. And even if the EA is not the core topic of the MRR work, any change of design that happens between FDR and MRR should be tracked on EA, because EA should be kept up to date for all the life cycle of your plant system. So even during operation, we should have a valid EA project. So now for the hardware, the two main deliverables are the cubicle wiring diagrams and the MIP, which is the manufacturing and inspection plan. That's it. So and then for the software at MRR, the main thing that we want to check is that the software development maturity will allow to freeze the hardware configuration. So if we have doubts at IO, or if you have doubts at DA that your hardware maybe you have doubts that the solution taken for your system you will not be able to develop the software for it, we should not allow to start the manufacturing. Maybe you will have to start completely from another solution. So it's we should not start the manufacturing of the cubicle. Okay, and after the MR, we will arrive to the manufacturing and testing phase. For the hardware, it means that we prepare the cubicle, we mount the hardware component in the cubicle, we wire them together, and we prepare everything. We test that everything is installed according to the plans, and then that's the end of the hardware aspects. The software development can continue, and we expect to have the software development plan, I will explain later, regularly updated so that we know where the software development stands. And at the end of the development, we need to have all the source codes and the user manual of the software to validate the software development. After that, we are back to a system activity where we load the software in the cubicle and we start to do the test. I put here a software development tree because I'm pretty sure in 100% of the case there will be additional software development. We will improve our algorithm. we will fix all the bugs that we have found during the test. And only when everything is fixed, we are happy with the algorithm, we know that we are meeting the requirements, then we have the official FAT, which is saying, okay, my system is ready for delivery. I show you with the system test report that everything is done. So this is, I try to have a very complete scheme, but keep with not too much detail so that you understand what is expected at which stage. So I will have a few words on the different deliverables that are expected. The first one is the INC system manufacturing. So the idea is really to present how to we are manufacturing the plant INC system. So I use the word manufacturing because it's what we use in ITER, but to be honest, it should be more an assembly activity than a manufacturing. So we are not manufacturing the cubicle doors and everything. We are buying a cubicle and we are doing the assembly. And the goal is to demonstrate that we are ready the system is ready to launch its manufacturing. The INC test plan at system level needs also to be developed with a starting development of the full test case. So we don't need to have all the test procedure finalized because very often that will require the software to be fully developed so that we can see really all the HMI, for example, to run the test. But we want to understand what you will test in each, what will be the process in each of the test case. And as I mentioned, we have to update the EA project all the time. So the INC SMS, I put here all the important links. So the presentation, all the presentation we have been showing are available on IDM. So you can after look at it and have the important link. So the links, we have made the INC SMS templates that need to be used to write the document. And we have done with a contractor, I will explain a bit later, we have done also a checklist which gives all the points that we are going to look when we are looking at your SMS. So with these two documents, what we hope is that we have only to recommend the SMS each time we receive a new SMS. And I put also an important link is the overall MRR instruction. So the last document, it's what we have been using to develop the SMS template. So we tried to take all the criteria that is asked at ITER level, which are relevant for the INC. So there is a lot of things about welding, about big machinery stuff that we escape. We try to focus on the INC aspect, what is relevant for INC, and we put it in the SMS template. So we didn't put anything to bother you in the template. It's everything which is something that is found in this instruction. So the main chapters I put here. So we start with the overall system description. We want to see the management process, how you are going to manage the procurement, how you're going to manage the manufacturing, the software development and everything. We want to see a sequence to understand for your particular system how you start doing if you have several cubicles, if you do one by one or if you do at the same time, when you expect to have your software finalized and so on. And after we have two big chapters about hardware manufacturing description and software and firmware programming. And we want to see what is, from your point of view, all the deliverables that you are going to produce at the manufacturing phase. And a few items on cubicle storage, handling, storage, two words, and transport. So this is the main aspect. Another very important document for an MRR is the INC cubicle wiring diagram. So we need to perform this wiring diagram with the SE Electrical Experts tool. So it is a requirement. It is a quite expensive software. So you have to think about how to get the software resource. I hope you all know Ranjit. He can support you to get also the trainings if you need to have trainings. To get how to be able to have the license on your side. What we want to see in this wiring diagram is all the internal wiring, the 2D layout of the cubicle. We need to know the termination diagram. It means each cable where the people will have to connect them into your cubicles, and the bill of materials. So this is the main point. That's it. So very important point, Ranjit or SXP expert is preparing a standard cubicle file, which will have already embedded, so everything which is very standard, like the electrical distribution, the network switch, the CMU. And maybe we'll do a few options. So you will be able to start from this version, and we will have all basically the same electrical distribution, and it will ease your work for passing the electrical inspection from the French certificate. Another important document is the MIP, the Manufacturing and Inspection Plan, which is purely a list of all the activities which are required for the hardware manufacturing. And it is an Excel file that is used to load the future manufacturing database. So just a few points on the cubicle configuration and the expectation at the PDR. It is widely accepted that you provide just an Excel file with the demonstration that you have thought about the cubicle space. At FDR, it's we would expect normally to have a type of AutoCAD drawing. And ultimately, at the MRR, at the last moment, we need to have the 2D layout done in SE Electrical Expert. So it was not done for all the cubicles we had so far, but for the ones we have already received, we will work with Ranjit to make it to post and delete. But ultimately, we will need to have the 2D layout in SE Electrical Expert. It will allow to have no mismatch between the 2D layout and the wiring diagram. An important point is the bill of material. Up to the FDR, the sole source of design is the EA project. Once we start the manufacturing design phase, the bill of material will be handled by the SE Electrical Expert. So at FDR in the BOM, we expect to have only the electronic components, so we don't expect you to list any circuit breakers, for example. Even the terminal box the terminal board is a bit more too detailed to be put in the EA project. But we need to, so in the SE Electrical will be the only source of bill of material. And if there is a change in the SE Electrical, it should be retrofitted to EA project. And we have also to keep the consistency with the SDD project. So this is a point that we have noticed recently, that we need to align, very important, the naming convention for EA and SDD on one side, and SXP and CLM. Which is then used once you have manufactured the cubicle. Each component needs to be stored in a database with the serial number. So before MRR, it's still a design, so it's not a real product. It's not a real component. It's a wish, let's say. Once you start to manufacture, you have ordered your components, so you know their serial numbers, and it has a particular serial number, and it needs to be recorded in CLM. And we need to have full consistency between CLM, SE Electrical Expert, EA project, and everything which is in the SDD project. So otherwise, in operation, we'll have an HMI, an alarm that PCF is not working, and nobody will know what is a PCF because it's written CPU in the database. So we really need to have a full match between these. MIP. So what is MIP? It has been very well presented by Hervé, so I will not spend much more time. So we have a pre-filled template, so you can use it. We put what we think is generically usually done. So your work will be very simple. It's just to check that you agree with our proposal. Maybe add a few activities that you think are important to be recorded. And you need to agree what you want to do with this activity. IO will not want to be involved in each line of this MIP, otherwise we will be completely blocking your system. So when you do wiring, we don't need to validate each time you've done a wiring. There will be a few hold points, but most of it you will sign off. You will maybe do your own review. So there is a column for the subcontractor, a column for the DA, and a column for IO. So you can decide who you want to take what type of action. And very important, you need to specify what is the expected record in this column. So we really advise you to put a lot of reports here. So it can be pictures. you have done the labeling of your cubicles. You want maybe it takes a few pictures so to show that how you have done it. It can be a certificate, or you can show that the people who have been doing the manufacturing is certified. It can be basic test report. It can be anything, but everything you put in this system, at the end, it will build automatically end of manufacturing report. So for the MR, you show the Excel file. We all agree. And then you load the Excel file into the database, and it becomes a very useful tool where you can just click on something, say, I have done it. If you need to have a recommendation by someone, it will send a mail automatically to the people you have pre-recorded. So it's very useful to work with. And again, at the end, you don't need to prepare any reports. You just click on Generate Report, and you have all the activities with the associated report that you have done. So this is a very powerful tool. So it should not be seen as a new burden for you to slow you down. It's really a very good tool for you to communicate with us on what you are doing, and also with you, DA. A lot of time we will not be the manufacturer. It's also a good tool for you to track what your manufacturer is doing. So if you are asking a company from your country to build a cubicle for you, you can use this tool to make sure that he sends the good report that you are expected. Okay, so software development. What I explained earlier is that the software development is mostly independent from the MRR process, so we don't manufacture software. Still, the point that needs to be addressed is the software maturity sufficient to allow the freezing of the hardware detail architecture. We would expect also at MRR that the SDD project is completed. So you can use EA to SDD tool normally to prepare your SDD project. So when I say completed, again, there can be updates, but we should have the SDD structure finalized. And you can present, so we expect also to have a software development and inspection plan version 1, which is not complete at all for MRR. I think I have a I have a detail here. So for MRR, we expect to have the exhaustive list of software packages with identified targets. So we want to make sure that you know which software you have to develop and to which targets you are going to load your software. During the software development, the SDIP will be a living document, again, which can be shared between you, your subcontractors, and IO, where we will have an updated versioning of the software with the current repository. We will put the inspection point from DA IO. So if you are done with a piece of software but not with the other, we can still say, okay, please review this part. We would like to get it approved. And we want to have also the dependencies and all the link to the reference documentation, mostly the user manual. And at FAT, we expect to have a frozen document, which is given together with the system. The system is one configuration. The software it's frozen with one configuration. And after maybe at SAT, maybe at commissioning, we will have a new update. But each time when we end a phase, we want to have this document frozen. So we have a first template, which is here. We have a lot of remarks already, so there will be an update on this one. And we will also produce some software checklists, but they are not ready yet. What are the other software deliverables? We expect to have a software architecture and design description, SADD, where we have the full detail of the software description. It was not yet identified, but Sukhmit, I think, will present in his presentation. It will be added in the guidelines. The software project management plan is a document that is requested in the Kodak ANC software development procedure. For us, it's fine to have it as a separate document or integrated in the INC SMS chapters. All the source codes will need to be uploaded on SVN, and we will really have a very careful look on the software manuals. So what we want to avoid is to have a good software validated by test plan, but nobody in IO is able to use it because first is not able to install it. So we want to have the two aspects: how to install it in our system, and after how to use it during operation. And the software test plan and test report. So it's up to you to decide if you want to have separate software test plan or report, or to have everything included in the STP. So the software development is currently under a lot of discussion. So we have not fixed ideas that we want to give you, and that's all. We are very happy if you are proposing ideas and concept, and we are a lot looking to what you are doing also. We start also to receive some software for some system. So we are not we try to follow always the Kodak procedure, but since we are a big system with all DAs involved, all contractors involved, very often we try to impose a bit of new rules. It's not new rules, but it's a way of doing, so that we get quite consistent things between all the DAs and all the system. But the idea is that we try to follow the Kodak procedure. And as of today, we are not we are open to get your ideas because you are the ones who are really working on the systems. So we really are in a mode where we accept any improvement proposal, and we are looking to the system that have developed something already to provide the guidance. I will try to be fast. So I just put here on this slide the extract from documents which explain what is a MRR. So I will not read everything, but all these points will be checked at MRR. So it goes from checking your ability to do, or the ability of your subcontractors, to the availability of the drawings and the detailed design documents. What is the outcome of the MRR is the decision to start the manufacturing. We still can have some open points at MRR and decide to go through manufacturing. So that's happened already. So for some MRR that we had is okay. You can start, but please before you reach this point, you need to fix a few things. I mentioned already. So all manufacturing steps shall be detailed and reported in a manufacturing database. We advise to have very limited hold point for I/O, maybe just the first power up and ready for FAT, because we will most probably be blocking you if you put us in every single steps. And the software development is always continuing. So don't work only on cubicle manufacturing or only on software. Everything can be done in parallel. And at the end of manufacturing, we expect that the basic tests are executed successfully, that the software can be loaded, and the system is ready to start the FAT test campaign. So not that it's ready for FAT to call a FAT, but to start the test. And an end of manufacturing report will be automatically generated by the MDB. Sorry. Okay, sorry. I had just two last slides to inform you about a new contract that we have with RAVE, which is Rosatom Western Europe, to support I/O during the diagnostic INC manufacturing. So they have 4 areas where they are supporting us. The manufacturing follow-up, so they are helping us to improve the manufacturing process, to follow up also what will be the status of the manufacturing of the cubicles, and to perform some manufacturing inspection. And they will do also verification and validation activities, checklists, preparation, and review. So all the checklists have put on in the reference. They were prepared by the team, and they will do also software codes inspection. They will also support the configuration, both network configuration and software configuration, and they will prepare some common solutions. So we have Ilya here. Maybe you can present yourself. If you open your mic, the camera will come to you normally.
Hello. Hello, you can see me.
Yeah. So it's important that you start to know the team. They will contact you. I think some of you have been already contacted to get some information. So for all the teams who have systems which are approaching the manufacturing design phase. And so we have also, so I don't know if Nikita, you are connected.
Yes, I'm here. I'm remotely. I can say just a couple of words. Yes, we're very happy to start this work for some time already, and we hope that our efforts will enable to make the manufacturing process easier for both IO and diagnostic teams. So we are ready to any support and any suggestions and proposals how to improve the manufacturing process, make it more clear and understandable.
Yeah. Thank you. So the last slide I wanted to explain also is the common solution. So it's one point for which they are going to support us. So what is a common solution? It's any technical solution that is developed by IO or by DA. It can be during prototyping or during what we call the reference system or during the system development. And the idea is that we have a design ready to be used by other system designer. So why using common solution? First, for you as a DA or as a contractor, it will save your development resources. So it's a big save for all the project. And also it has a good aspect is that it's a unified architecture of the diagnostic system. So each, if you are all following the same design for the solution, you will not have 10 different solutions to use and to maintain. So that's also to reduce the cost of maintenance. And how to use this common solution? So IO will prepare the packages supported by Rave, where we will have the EA project, or sometimes maybe just the FBS and the signal and component list, detailed architecture and BOM, the software architecture, and also the software package that are delivered with the solution. So we have identified a list of 6 common solutions that is already prepared in the contract, which is the thermocouple monitoring, the mirror cleaning operation, the temperature control through baking jackets, the piezomotor controller, the imaging system, and ADC with FPGA in micro TCA form factor. So all of them are systems that have been developed for reference system or system development. And in the future, we encourage the DA and other IO contractors to look to what is existing before inventing something new, and to share the developments between similar systems. So we have we will have to identify new common solutions, and we will support you also to share and to harmonize everything so that we save time and we have a common approach. So that's all. If you have any questions. Yes.
I guess I have a couple of questions. So on the current slide that you have, it says how to use common solutions, and I will prepare the package like EA project, hardware architecture. This is at the MRR level, that because we would be developing EA and all the stuff from the PDR level onwards.
So each situation is a bit different, but for example, for the thermocouple monitoring, we are going to use actually what the CA team has prepared, which is going up to almost a fat tested solution. But you will get the FBS, the signal and component list that you can use at PDR. Okay. And you can take the rest when you need them. So the idea is that you get the the PDR part for your PDR, and you use the more detailed part later on. Okay. But the idea is you have a package and you know how to use it. You just have to transform we will provide, for example, the FBS in an Excel format, and you can copy paste the parts which are interesting and put them in your FBS, and then you know that it will work and it will be accepted by IO.
Okay. And the other question I had was for the SDD project. So before entering the MRR phase, are you expecting the SDD project to be ready with all instrumentations mapped out in there and simulated perhaps?
No, what is expected is that for so at the end of the manufacturing design phase, let's put it this way. At the end of the manufacturing design phase, we need to you should be able to create the SDD project from your EA file. So you can use the EA to SDD tool. At the moment, it will be working pretty well, and you can start to complete all the manual parts of your software in the SDD. The idea is that you should know at MR all your hardware, so all the software units that you will need to have in the SDD.
Okay, so at MRR phase, we would have to have a SDD project ready, and that is working. Okay, all right, thank you.
After, if you see some issues with that, I'm happy to listen. I don't say that 100% can be done. Maybe there are aspects that will be improved during software development too, but the idea is really that we should have a full software structure known. So we cannot have the hardware in manufacturing while we still are wondering how to organize our software.
Okay, thank you.
You're welcome.
I have a question if nobody else has one.
Yeah.
So on your slide 10, you had slide 10. So I see you representing the cubicle layouts in both the the Excel spreadsheet type, kind of cartoonish, as well as a nice CAD quality diagram. In terms of the CAD quality diagram, is there a template that we can use for our own cubicle layouts? It seems like there's common components that are being passed around or used.
Yeah, we have. We should have all the CAD files that have been used. So maybe we should try to have a library of all the cubicles that we have so far with the PDF and the AutoCAD file, so that you save time
this
also.
This is AutoCAD that is being used, because I imagine we're at some point going to have to have a deliverable of this quality.
Yes, this is AutoCAD. So after we need to check with Ranjit. So what Ranjit is doing is preparing 2D layouts in SXP directly.
Okay.
So I want to get also his feedback. Is it not a loss of time to do a very detailed AutoCAD drawing in FDR if we know already that you are going to use SXP after? Okay. So we will provide you. We can provide you. The idea is to share everything. So all the AutoCAD files that we have received so far. And it's true that you will find already a lot of reference that you can reuse directly. Okay. But in the future, if we are able to do it directly in SXP, then we save some time. Right now, I didn't have a good diagram to show to you because it's the first one we do was for the standard electrical distribution. Mm-hmm. But in the future, we will consider if it's not more efficient to start directly from SXP.
And while we're on cubicles, we have an issue that's come up on our diagnostic where we have some low voltage AC power 240 volt equipment that isn't to be placed in our cubicle. It's associated with our laser table, like laser power supply, chillers. And NAX0 is saying that they're only providing electrical power to cubicles. So does that mean that we're supposed to be using our INC cubicles as a power distribution branch for high loads downstream?
That's unfortunate. So I need to discuss with NX0 team. The process, as I have understood, was that we can declare in the EPCT, in the electrical power collection table, any needs that we have. And if you have a need which is not in a cubicle, we should have the possibility to have a direct connection from the BP to your whatever is on your table, but it needs to be declared in your cabling diagram. That's you cannot just expect to have the power coming out of nowhere. It should be identified, a connection from the BP to your device, and it's not even in your diagram. It should be in NX0 diagram that they have identified. So maybe that's what's blocking, is that they need to update their diagram to include it, and the problem also is that the BP, they are not only designed, not only manufactured, they are installed on site. So if you need...
but we haven't gone to PDR yet, so I mean, we need...
That's ITER problem. Yeah. So yeah, we'll have a lot of this issue, but clearly you will see tomorrow all the BP are installed in a specific configuration. They have a lot of spare. So it will not be in a dramatic situation, but everything will go through a change process. You will ask NX0, I want a new, I have a new client, which is my optical table. I need to check if really there is a reason why only a cubicle should be put. I don't see any reason. I see Vincent, maybe.
Yeah, maybe I can quickly comment on that. Basically, you have to declare your needs as Arthur just said through the applicable, let's say, technical documents. It should be as well clearly stated in the interface sheet with NX0, as we used to do with, any other kind of services. So this is a place to agree on the interface points. Here for electrical services, it means where you need power for what and so. And this is managed by IO, this interface sheet. So this is also important. So this process, let's say, to consider the update of this interface sheet between NX0 and your system.
So Alessandro Danici is the responsible for the NX0 system, and is the person to Alessandro Danici.
Yeah. And Daniel, and it has to go through the IO TRO because this is under IO responsibility as well. Yeah. So you talk to me. Yeah.
It's for tip. So yeah, you should. Obviously, you should ask Christopher and Alessandro Danici. Okay. Yes, Hervé.
That's not the fun stuff you want to talk about at this workshop, but these are.
No, that's exactly okay, for tomorrow site tour. So we will insist on this point to show you what is already fixed. So to make you realize that we don't need just to change document, but we have now a long process for that. So clearly we want your system to be working. So we will support you, but now it's a bit more complex than it used to be, and there is a full process to tackle. Hervé?
Yes, if I can complete your answer, there is also the interface sheet document where you can specify the communication between which part and another. And I don't know if there is dedicated part in the interface sheet to specify the input voltage or some specific requirement.
There are two interface sheets. We have interface sheet with Kodak for the network and interface sheet with NX0 for the electrical power.
Interface sheets said to complete the electrical power collection tables.
Yes.
Which had been done years ago.
Yeah.
And it was specified that we had external equipment, but now they're saying that.
Okay, that I taken the action to check because I need to understand technically why they're saying that, and then maybe.
That leaves us, are we supposed to route our own conduit, electrical conduit on the floor,
yeah.
Cubicles, put breakers and INC cubicles, power equipment and voltage areas with diagnostic.
Yeah. So okay, technically I think it's feasible. First, so don't worry if we end up doing that. It's not a dead end, but I will check if it's really the best solution. So, any other question? We can go to the next agenda item.
Yeah. The next one is just an open session. So we have Maximus and Isabel connected online to this meeting. So if you have questions on anything related to operations, now is the time to ask them. And Livio, would you start?
Yeah, so I would start.
Maybe please, you can share your screen. And
yes, wait a bit. So this is the typical table that we have in the EAs.
It's a microphone a bit closer to you, Mr. Rost.
Closer to your mouth. Okay. Is it better now? So just wanted to clarify then on the mappings that we have in the EAs on one side. So we have normally included a table like this with COS commands and then pesos, and then corresponding pesos and the COS state. First question related to this is how, when we can expect that the system receives the COS operation request and then that is propagated as pesos and changes states, or and when it's just the pesos command then. So when this is related to the states when we are going into the pulse mode, or we always need to think that we need to even locally generate first via COS command, which then that triggers a change of state.
Okay, I can attempt to answer something. But I guess this was more a question for Walter. But as far as I'm aware, the cost must also be determined by you. So you have a pesos, okay?
Yes,
you need to
yes.
also define an internal cost. So you define an internal cost, you map it, okay? And this must map to the global cost, okay?
Yes,
I
so
think
this,
this
we
is how
added
it's
this
done.
table. Yeah. So we think of that by, for example, on the right side. So this is a table which we added because it was we found the need for it. So each pesos state on the right then has a translation to a cost state. So we can provide that. We can see also that in this case, for example, some costs states are not, we don't implement something directly, so especially the transition ones. Is that also something, or the other question, is it a problem if, for example, terminating,
When you say you
aborting?
don't implement,
So
when
can
you
I
say
ask?
you don't implement, go on, Isabel, sorry.
No, it was just a clarification. When you say you don't implement aborting, so if you receive a signal from SOUP that says you have to, we are aborting the pulse, how do you implement that? What do you do?
That's a good question. So we can receive that, but we jump to the next step. Let me share maybe then something
Okay.
else.
But you can actuate. Yeah.
Yes, we can.
Okay.
We can act to it. So it would be. So this is how the states look, and then on our side, so we just don't have in here in aborting because we go directly back to configured for measurement, which is corresponding to COS ready, for example. So we can react, yes, to it. We didn't saw the need to put something aborting because the transition in this case was very fast. We don't need to show that it's staying
it's gone
there.
through okay, another state. Okay.
Yes. But we need, so getting back to the original question, do we need to always think in going via triggering even our all our states via COS transition requests, or because we have some commands pesos transition or COS transition? This is sometimes not so clear how to manage it.
Yeah,
Always
I think
coming from the higher.
Yeah, I don't. I think Walter has to answer the question. I think, if I remember correctly, is always pesos. Okay, so not COS, but you have to ask Walter.
Because the question is rather when we go into here, when we say ready and SOUP takes over, we might expect that the command comes from above, and that's why, well, if they just ask us, okay, what's the type of command you expect, rather pesos or COS? Well, that's, we can agree, but just to know if there is a constraint on that. So that's one part. Another thing is especially operation outside plasma pulse. If there is any constraint that we need. So this is, for example, for a system which in POS will only stay shut down. So it's erosion monitor, which will go in complete measurement in test and conditioning. And we can always provide the equivalent costs. But if we have any constraints for that, we consider currently no. So we will be costs running outside Plasma Pulse.
Sorry, you will be using the same cause as for Pulse as outside. Using the cause outside Plasma Pulse.
The same mapping.
Yes. Okay. Yes.
Yes.
Okay. Maybe you can simplify. I don't know, but yeah.
But it will not be a system required for Plasma, so
okay.
it's okay if we report shutdown during Plasma.
Well, I think this is one of the systems that has to be off. So SOUP has to confirm that it is off during Plasma Pulse, no? So you have to have some, I don't know if I understood yeah, you have power off. So you have to say you are off and you cannot be in operations. You cannot be called, yeah? I don't know if I understood your question.
So SOUP will enforce us if we provide the mapping. So what is SOUP expecting from us? We say the mapping, and then it also enforces that we are not gonna do something different.
Well, yes, in a sense. So one of the things that we have 3 levels of requirements, let's say. So if a system, if your diagnostic is required for operation, SOUP knows, and it will like abort the pulse if the system is not ready. If it's not required for operation, or if it's to be excluded from operation, so Kodak SOUP needs to ensure that this system will not become live during a pulse. Okay, so I don't know how this is ensured. This is what that's why I think Walter is important to be here to answer your question. But we will declare for a pulse that your system has to be out, so excluded.
We have
in the sense. Sorry.
We have Damien who makes some signs. I think he can maybe answer.
Thanks. I just wanted to quickly summarize the main points that you made. The system is operated outside of a pulse. Then, indeed, as Isabel says, you can define your operational cycle in terms of cause. But in the latest operational procedure, it says that cause is only for post-operation. So you might as well define the semantics and the meaning of the state machine that you need for your operation, and then agree that with the operations, if you like.
Sorry, cause is not for operation only.
For post-operation, that's what it says in the latest document. It's only for post-operation. So if the diagnostic is used in pulse, then cause applies. But if the diagnostic is used outside of pulse, and that's always going to be the case, then perhaps cause is not a suitable abstraction to define your operational cycle. And so maybe it is worthwhile to define your own state machine. Second, if you can go to the cause definition.
This one?
The one that would do. You will notice that these 2 types of arrows used here.
Yeah, the commands.
Yeah, one of the types of arrows is that the event comes from the outside, normally comes from SOUP, okay? And then the other arrow is for when there is most likely an automatic decision, okay? Now, for those diagnostics that are operated in pulse, it is very important that you maintain the structure, okay? Because otherwise we'll be very confused about, especially, so I work for Interlocks. We are not directly working with the cause, but we draw a lot of our information from it, and we'll be very confused about how the plant is operating if the plants are in different states implementing different transitions. So impulse operation INC should really follow the cause. And here you have the transitions that are requested from SOUP. They're requested to all the plants simultaneously. And then if one plant says, I cannot proceed, I have to abort, then as shown on that diagram, all plants have to respect the fact that one aborted. And then SOUP says, I want you all to abort and you all have to respect that. Okay, and then that way the post is aborted. So there are certain subtleties here that require a elaborated explanation that cannot be given now. But my advice, and of course Isabel can confirm, my advice is that if your diagnostic is operated out of pulse, to make sure that your state machine fits the operations that you require, and you don't mess with cause at all, because then the whole concept of cause is diluted. Cause is very important for the impulse operation diagnostics.
So outside the plasma pulse, we don't even need to report cause, or?
Well, I think there's something, I don't know which diagnostics you're from, maybe it was written somewhere. But it seems that there is
erosion monitor G8.
Erosion monitor. So this is something that like a laser that is then is inserted in the vacuum vessel. Okay, well that's a typical kind of interlock example, which actually we'll discuss tomorrow perhaps. But it seems to me that the pulse shall not start if your diagnostic is deployed. Now you can say SOUP is good enough to protect against this mistake. Or you can say SOUP is not good enough because SOUP is not really an interlock system, okay? So really here we are discussing across two different types of requirements. One is how important is it that you don't mess with the cause? What could happen? Well, of course, if we start the PF colloidal cause, you may destroy probably any equipment that your diagnostic has deployed inside. So that's something to consider.
We are not the ones who decide this type of thing. So it's machine protection panel who needs to identify whether it is a risk on the tokamak operation or not. So
can we go back to the control? Sorry, can I ask a question? So how do you deploy the system? Who is in control? Do you control the system, or do you require that? Do we require some other?
We can control. We control standalone.
You have a control plan, let's say, that you can control the system, but nevertheless you need to be connected to SOUP because we need to know that you are operating the system, and we need to give you authorization to operate the system. So in that sense,
and we need.
Go ahead.
And what do we need to report then to SOUP in that case? So we need also to report cost state then.
This is what I don't know. I think here you need to talk with Walter, because it might be that you only need to report PSOS. You don't need to go to COS. Okay, so for us operations, since we are, I mean, this is only for control of your system and all. We don't, since it's not a pulse, I don't think that is a requirement to use COS. So I think it's better to talk with Walter what he proposes for you to use in your situation.
Okay, thanks. But then one comment with respect to the request-driven transition. So that means from this one, for example, that we should expect for a system operating during plasma that it would also be requested to go off. So practically all over, not just. So that's correct then, no? So also going in local, then SOUP can ask. This was not our.
Well, local means more that you are asking. So it's not SOUP that asks to go local. So if you need to do some tests, for example, to your diagnostic.
Yes, that's what we thought, but this arrow type then would indicate that it's, if I understood it correct, that's rather coming from above.
But it is under your. It is under your request. So you request and SOUP gives you authorization or something like that. Okay, it's not very clear. I agree.
Okay. Okay, that's one thing, and that means the other arrows which don't have like that then you mentioned that can happen automatically. But there was one comment at some point in the exchanges with Sugmit that we expect that transitions should be triggered by a command, or they can also be happening automatically by monitoring a set of conditions, for example.
I think there is a long-standing trouble with that diagram, and I recognize this. One example I can give you immediately here is that the transition from initializing to aborting for your plant or for any plant doesn't need to be externally requested. You are initializing, you have a problem, and you go into aborting. Okay, but it is a requirement that if you have initialized, okay, and then SOUP says aborting, then you must respect that. So there are problems with this diagram. I'm in discussion with Isabel about fixing it. I think the best approach for now is to ask these questions directly to Isabel and to Maximus, and I've been supporting them on actually redefining this as much as I can. But at the moment, I think it is. I also agree it is confusing.
Well, we can understand that where we have a request-driven transition, it can happen that it's also understood that it can, in some case, be automated. As you said, okay, in some cases it's automated, but that means that it can also be. So some can never be request-driven.
No, the transition from not ready to local is again external. You are sitting in the Kodak control room and you press a button and you ask the system to go into local control mode. Okay, so again, under the control of Kodak, under an external request, you are switching the system into a mode, into a state from where you will operate it in local control. And that should be reflected centrally, of course, so that we know that the system is out of the loop. So that is, I think, accurate there. What I'm not sure about is this not ready to off transition, which is by external request. Clearly, anything below not ready should be automatic. It should be the system being essentially rebooted, restarted, installed, whatever. And then at one point it is booted, started, ready to be configured, but not ready to enter a pulse. So all of these things need to be revisited, in my view. I've been trying to push these points, that the same thing you're asking about. I understand exactly your concern, and I'm trying to push them for clarification, because clearly it basically is confusing as written right now.
Okay, thank you for clarifications. Then just to repeat one of the last questions, can a transition be also without issuing a command? I think not, from what you say. But if we define typically a set of smart conditions, checking the different states, and at some point we lose some of them. That, for example, what should happen in that case? We should issue also a command making a transition and not just change state to the new state which corresponds to the new state of smart conditions.
Can you provide an example a little bit?
Yeah, let's look, for example, in this. We have, for example, on the columns, there are different states, and they are identified by the values of a list of variables here, which are monitoring different functionalities. And we have reached, for example, the state prepared for measurement, where these ones are true and some other ones are false, and something happens in the system and one of these ones true change to false, and then it's no longer corresponding to that state, and we should either degrade to other.
It depends on the impact. It really depends on the impact.
No.
If one of them goes to false, Well, it depends. We have to evaluate this
Sorry,
MPP.
as I said, all the systems that are in a pulse, and this is in a pulse, they have also the qualification of required, excluded, or not required. Okay, so if one of these systems is in required, and if it presents a false when it's supposed to be true, so it goes into not ready, we abort the pulse. Okay. So you cannot change, or maybe you can be given a certain like time in order to see if you can recover the diagnostic. But if it is a required diagnostic, we will go into abort. Okay, because this system is not ready.
Before taking to the decision that we abort, we let that message known by getting the system into aborting, no, or we don't change.
No, you tell so soup receives that you are not ready. Okay, so you go into false. Suddenly you are outside, and soup will abort the pulse.
So we would go to fault, not degrading according. For example, here, if for example we lose through the last ones here, we don't just degrade to performing final checks this other state, but we go fault. Yeah.
We go back to the beginning. Yes, we abort and we go back to the beginning. If you are a not required system, okay, then we will continue and you will be in false, but okay, we don't get the measurements, but we will continue the pulse.
Yes, I understand. You already say more than what I asked, because you say what happens with the whole system. The question was just if we also issue a transition command, but I think that's minor compared to.
So we are talking about a non-pulse operated system. This is the chart.
This was out. So we work on several systems. So this, let's say, it's in the pulse. So that's also, we have cases like that also.
Okay. I mean, this will be delegated to something called local protection functions. Okay, so it may be that you have to put the plant in a safe state because suddenly you are ready for measurement here. I suppose the probe is extended into the vacuum vessel, and then you lose one of the preconditions for safely operating the probe in the vacuum vessel. Okay, so perhaps your INC should retract the probe for not safety, but for assuring that, so it may be that automatically you take the decision to retract the probe is good enough. However, in certain states of the cause, so now I'm talking about post-operated diagnostic, you cannot do that. So for example, if you've showed initialized, right, you have to be ready to execute the pulse. Okay, that's it. If you are ready, it means that if soup requests to go into countdown, you will go into countdown. Okay, and that's also something to add to this diagram: which transitions are mandatory and which are essentially not.
Okay, thank you. I think I covered all I had on my list. Thank you.
Thank you, Livio, for the question. I think it's a question that a lot of people will have not raised to themselves, but the discussion is very important. So, is there any other questions? So, operation is quite a wide concept for ITER. It's I think, as we have seen for this example, there are interpretation of some diagrams that some people will have in a way, some other people in another way. So we don't yes.
Can I make just a comment on this? I think this is very well that this is raised. Okay, it is clear that some of these things have not been properly defined or addressed. I don't think we can answer don't answer correctly most of the questions that were raised at this point, and we have to work into answering them. So I think it's a good start, but we should make some actions to try to define all these things in more detail. Okay, so this is an action for ITER internally. It's not only for operations, it's for Kodak. And it's good that they are raised here, but we can definitely not answer them.
Yeah, for sure. We don't expect to have everything fixed today. So, sharing the issue is also helping you to improve your concept. So, any other points you want to share?
Hello one more time, colleagues. I have one question to, I think, Maximus and Isabel about concept of operations. Do you hear me?
Yes, we can hear you very well.
Yes, thank you. For now, from LFDA and our colleagues, we have several concept of operation documents for diagnostics on IDM. Some of them are approved and some are still in work. And for now, we have several questions about, I want to name it balance between template and quantity and quality of description of operation topics for diagnostics in terms of quantity of modes and detailization and mappings and relations to procedures, to states, and to our related things. So it will be very helpful for our work if we can share one example in nearest future with Isabel and Maximus for something like peer review and discuss about several questions. It will speed up our work with DNFM and several other systems. So my question is, can we perform some discussion or email connection to discuss a new version of ConOps, for example, for DNFM, when to use that approach for several other systems?
Yes, absolutely. We can have a discussion in detail. We can go through also, we have a lot of concepts of operation now of various quality and detail. Some of them are a bit better, some of them are not so detailed. Some of them are for very simple systems, so they are by definition simpler. Some are more complicated and they have a lot more content. We can sort of go through a few examples and see what are the best ones. Actually, I'm going through this exercise now, going through them and looking at what are the best general features which ideally all systems should implement. And we can definitely have a discussion on this. I think it is really worthwhile at this point. We have also just now, it was approved recently, we have a new version of the template, which is just basically incorporate some lessons learned from the previous exercise of completing them. And by all means, we can go through this whenever you want, and we can find what are the best ways to fill this document for diagnostics, for your diagnostics.
Thank you, Frank. Well, yes, because we have several rounds for different systems on IDM with comments, and I think that some comments are a little out of scope of templates, and it's more simple to discuss it before new publications. Thank you.
Yes, okay. It will be a pleasure.
Yeah. If we have a safety components that are going to the safety control system, how does that get represented in this cost and PSOS mapping? Because it would be controlled by the central safety.
Yeah, I see. Maybe Damian, if you have a good answer.
So the cause is to do with soup only, okay? And I see like plant interlock systems and safety systems, they act as guards to you transitioning from one state to another. So, for example, if the safety system says you cannot go into ready, so you're not ready, and then the plant interlock system or the safety system is saying don't go to ready, okay, then basically your conventional state machine cannot go into ready, and then you cannot report to SUP that you're ready. So they act as guards in these transitions, and that's why the PSOS is so important, because the PSOS captures all of this detail. But the COS cannot capture this detail. We need to work with an adequate abstraction.
So we have a laser system, which after the system is ready, we make it a trip for the safety system. So if there is an enclosure opening on the optical table, or there is something to do with laser interlocks, then we're going to have a safety trip there. So that gets kicked back to not ready then?
I think this is your job as INC designer that when your system gets a safety interlock, you will get there will be a PV. So in addition to switching off your power supply, there will be a PV stating that the safety action occurred. So you should record this PV, and when you receive such PV, put yourself in the right mode. So here, if your laser is power supply, you are in abnormal or in whatever modes that you have defined. But it's your work. It's not the safety system that will put your system in the modes. They don't know your system. They just don't want you to operate your laser because of human risk. And you, as the INC designer, needs to associate the event of safety function that occurred to the right place of your PSOS.
Okay. Okay, thank you.
I think in the diagram, we cannot see it now, but I think in the diagram from ready to not ready is not a request-driven transition, right? I think that's the case. So you ready means that if SUP says countdown starts, you're ready for countdown. If you're not ready for countdown because the safety interlock says you're not ready, you cannot report to SUP that you're ready. That's all.
Yeah, my question was more when we are ready and if there is a trip, which I think Alex answered that. Thank you.
Well, sorry, that's a very simple thing to answer. So if you're in ready and the countdown arrives, so SUP says countdown, your next state is abort because it's after the countdown. But if the SUP has not said SUP has not triggered the countdown yet, then your next state is not ready. Okay. Right?
Okay, so if in the ready state, if there is interlock or safety kick out, then we go to abort and not back to ready, not ready, sorry.
Or you can go to fault also. There's also the fault.
So it's up to us to decide.
I think here maybe fault is the right state because something wrong happened, someone opened the door or whatever, so it's a fault and you have to fix the fault before you can go back to ready.
Isabel anda anos, outro gajo anda anos a fazer esta merda. Isto que é uma cena importante e básica para na operação, que a gente está sempre a entrar em cima disto e a fazer coisas como deve ser. Epá, isto está há anos, quase assim, mudam umas merdocas e a gente chega a estas alturas e a malta para problemas e os gajos não sabem responder.
Mute this guy, I think.
I think we are very close to the time, at least for the people who take the bus. So I think we should maybe conclude for today. So first of all, thank you everyone for coming to this workshop. Thank you also for the ones who have connected remotely. It was very, we are very happy to see so many faces. So for tomorrow, we will come back. So it's the same room tomorrow. So we are all again in the same room. We have, again, a very dense program, so we'll try to start on time. Of course, if there is an issue with the traffic, we will wait a bit that all the buses are arrived. There are, again, a clarification meeting at the end of the day, and the topics are especially PCS, safety, and interlock. So if you have any question, if you can prepare questions already, that would be appreciated, because we didn't ask the intervenants to prepare a presentation, so it's really they come here to answer your questions. So that's really appreciated. Tomorrow we'll do a site visit. We have organized everything so that you will get all the protective equipment. We'll try to visit the main control room, diagnostic building, and if we have more time, we'll visit also the assembly hall, where you can see the TF coil and the vacuum vessel very close by. So I wish you all a very good evening. Try to digest all the information and come back tomorrow in a not too tired mode. Stefan, you want to say?
I'm very pleased with the discussions taking place. We call it workshop, but it's mainly presentations. So you are allowed to stop us and ask all the questions you have, and we take the time for it.
And just the last message, Dimitri lost his headphone. If you see some headphones hanging out, we got them. So I will take them and we'll give it back to him.
And maybe one message is that since we are here face to face and meet each other, use the opportunity to meet other people. And if you need to know who is working on similar systems and may be able to answer some of your questions in discussions, contact me and Arthur, and we'll get you connected.